Hey everyone, and welcome back. Today, we are going to dive into a concept that feels like it was ripped straight out of a comic book or a sci-fi movie, the idea of walking right through solid walls. So let's just get right to the big question, right? Is it actually possible? Can a person, or anything for that matter, just phase through a solid barrier like a ghost? Well, the answer is this really cool mix of yes and no. For us, here in our big everyday world, sorry to say, it's a hard no. But if you shrink down to the bizarre, mind-bending world of quantum physics, for the tiniest particles in the universe, it's not just possible, it's happening all the time. And this incredible ability has an awesome name, the quantum tunnel. Seriously, you can think of it as physics' ultimate cheat code, allowing particles to just ignore the rules we all have to live by. Okay, so here's the textbook definition. Quantum tunneling is when a particle, say an electron, zips right through an energy barrier that it shouldn't have enough energy to get over. It doesn't climb the barrier, it just appears on the other side. It's almost like teleportation. This analogy makes it super clear. So in our normal, classical world, if you roll a ball at a hill, it needs enough oomph to get over the top. If it doesn't, it just rolls back down, right? Simple. But in the quantum world, particles are weird. They're not just little balls. They act like waves of probability, and that wave isn't stuck in one spot. A little piece of that wave can actually leak through the hill, and if that happens, poof, the particle just materializes on the other side. It tunneled through. For the longest time, everyone thought this weird trick was only for single tiny particles. But that has all changed, and the discovery is so big, it just won a Nobel Prize. Yeah, for nearly 100 years, scientists could see this tunneling effect, but it was always with one particle at a time. One little electron here, a single proton there. It seemed to be a rule that only applied to the smallest things imaginable. Until now. And this is the whole reason we're talking about this today. For the very first time, scientists have actually seen quantum tunneling happen on a macroscopic scale. That's not tiny, that's big. This is a complete game changer for physics. And when we say macroscopic, we really mean it. We are not talking about a few atoms here. We are talking about billions of atoms, all inside a special superconducting ring, all acting in perfect sync like one giant quantum object. And this whole massive group tunneled through a barrier together. I mean, the scale of that is just, it's incredible. And this quote really sums up why it's such a big deal. This discovery builds a bridge. It connects the super weird rules of the tiny quantum world with the normal, everyday physics of the large-scale world we actually live in. It shows that these two worlds aren't as separate as we always thought. Okay, so what's the big takeaway here? Why should we care about some strange experiment with a ring? Well, this isn't just a cool science fact. This kind of breakthrough could genuinely lead to world-changing technology. I mean, look at this potential. If we can control these huge quantum objects, we could build quantum computers that are way more powerful and stable than anything we have today. We could create sensors so precise they could detect tiny gravitational waves or map minerals deep underground. And of course, it just completely deepens our understanding of reality itself. We're literally rewriting the rulebook. But this achievement, as huge as it is, isn't the finish line. You've got to see it as a launching pad. It's kicking off a whole new wave of incredible physics research. Just look at this timeline. You can see how things are speeding up. We went from just predicting this stuff a century ago to seeing it with single particles. And now today, a Nobel Prize for seeing it on a massive scale. It just makes you wonder, what's 2025 going to bring? What's next? Well, scientists are pushing hard on a few massive frontiers. They're chasing something called quantum supremacy, which is the moment a quantum computer can solve a problem no classical computer ever could. They're hunting for the theory of everything, and, they're trying to finally figure out what dark matter and dark energy actually are. And that theory of everything, that's kind of the holy grail of physics. The whole goal is to find one single beautiful theory that perfectly explains both the quantum world of the super small and Einstein's theory of general relativity for the super large. And you see, this Nobel Prize, by connecting the small and the large, it's a huge step on that journey. So I'll just leave you with this final thought. We just learned that billions of atoms working together can do the impossible and basically walk through a wall. If a rule of reality that we thought was unbreakable is actually this flexible, what other rules are just out there waiting for us to find a way to break them? What else don't we know about the universe?